Okay, now let's have a look at three-dimensional problems involving maximum and minimum. Okay, three-dimensional are typically now going to start involving your volume and your surface area. So make sure that you have really got your head around how we put those formulas together. Okay. We have got a rectangular container, has a square base and contains 1 liter of milk. Okay. The container has a folding lid that covers 3 times the area of the base. Okay, so that's a little bit interesting. The length of the side of the square base is x centimeters, the height is h centimeters. Right, so there's our milk carton, okay? So we've got this area of the base over here. And then we've got these flaps. So we don't just have one lid that's kind of the same as the bottom there. We have another 3 of them. So do you agree with me here? We're sitting with 4 of those squares that were the area of the base. So there's going to be a slight modification when we work with the surface area formula. Okay, just be aware of that. Right, so what else have we said? We've got the length and the breadth of the base, which is x, and the height, which is 8. Okay, great. This is a pretty typical way of how they would ask you this. They've said, show that the area of the cardboard used to make the box is A equals, and they've given you the formula. So very often what they're going to do is they'll actually guide you. They give you like this little helping hand and they say, this is what the answer should look like, okay? You just have to get there. You have to prove it, okay? Now, like this big, absolute, major no-no is that you are not under any circumstances allowed to actually use the formula that they've given you and kind of like do some funny thing where you work backwards to prove that it's true or something. Don't touch that, okay? You have to just use that to kind of say, okay, that's what I need to get to at the end. All right. But there is a little helping hand. It is a guiding tool to sort of say, well, that's the goal. That's what you need to get to. So work towards it. Okay. So we need to find the area of the box. Show the area of the cardboard used for the box. So do you agree with me that calculating the area of the cardboard used for the box, that's surface area, okay? So the first thing we're going to have to do here is come up with a surface area formula, okay? Hang on. Let's just stop for 1 second. I'm spotting a problem, all right? Do you see, let's see if we can change our color of our highlighter quickly. Let's make it green. Do you see I've got an x variable, and then I've got this very frustrating h variable over there. I can't work with more than one variable, okay? It's going to cause chaos. I can't do it. If you look at the formula that they're actually wanting you to get to, can you see that in this formula there are no h's there, okay? H does not exist in that formula. So it would kind of make sense, or at least I hope it would to you, that you need to try get rid of that h and write it in terms of x, okay? Why do you think they told us this, okay? It wasn't because they felt like telling us that it was just a 1 liter box of milk. It's there for a reason, okay? They're wanting us to use that in our efforts to write h in terms of x, okay? And this is what they're wanting you to figure out. Volume. The volume of your box is basically 1 liter, okay? Now, the volume of a rectangular prism like this would be the length times the breadth times the height, okay? So for the volume of this box, I would take my x times my x times my h, okay? The volume being 1 liter. Now, 1 liter, just using this value of 1 is not going to be so friendly for us, but let's change 1 liter into 1,000 milliliters, okay? And 1,000 milliliters is equal to x squared times h, which means that to get h entirely on its own, I would say 1,000 divided by x squared is going to be equal to h. So can you see now I don't have to write it as h anymore. So let's take it away. Let's erase it. And we are going to write it rather as 1,000 over x squared. Okay. Now we've gotten rid of that problem of it being 2 different variables. Okay. Now that we've done that, now we want to establish this, we want to get to that, all right? And we said that that's going to require surface area. So I'm actually going to do the working out on the side over here, just so I don't have to keep moving backwards and forwards. And let's try and see if we can get it in here. Right, the surface area of a rectangular prism is typically going to be this. The area of the base, all right, times by 2. Okay, I'm just going with the standard formula for now. Why did we times it by 2? Because of the bottom and the top. And then what we did onto that is we added the perimeter of that same base, so the perimeter of this base over here, and we multiplied it by the height of the shape. And that gave you surface area, all right? Now, as I said, this is going to require a little bit of modifying because this yellow base over here had 3 flaps on the top, okay? So we're not just timesing the area of the base by just 2. Do you agree with me? We're going to times it by 4 because we've got 4 little yellow blocks there. So in this particular example, we're going to have to just modify that to say multiplied by 4, okay? All right, so let's see. The surface area will then be the area of the base, which is x times x. So I'm going to say x squared, all right? And we're going to have to multiply that by 4 because we said there were the 4 yellow flaps. Plus the perimeter of the base. If I take the perimeter of this base, it's x plus x plus x plus x, which is giving us 4x. And we are multiplying it by the entire height, which is 1,000 over x squared. 1,000 over x squared, okay? What does that give me if I'm going to have to write it on the side, forgive me. We're going to have to then simplify that as 4x squared. And if I simplify here, let's just change my pen color quickly. That x is going to cancel with one of those x's down below there to leave me with 4 times by 1,000, which is 4,000 over x. Have we managed to get the formula that they said we needed to get to? Yes. Okay, so we used all that information to help us get to the formula we needed. Now that we have done that, they've said determine the dimensions, the lengths, the breadths, the heights of the container so that the quantity of cardboard will be as small as possible. Okay, they're being eco-friendly. They're trying to keep the amount of cardboard that they use down to a minimum, all right? Well, just as we said, minimum and maximum gets calculated by working out derivative and letting the derivative equal 0. So if the formula for the surface area of your cardboard is given or is worked out to be 4x squared plus 4,000 over x, then just like we've been doing in the previous examples, we are going to have to calculate the derivative of the surface area in terms of x, and we're going to have to let it equal 0. Okay. Before we can find the derivative of this function, what is going to have to happen to that x over there? Do you agree the first thing we're going to have to do is bring it up because we can't use our rules of differentiation if we have got a variable in the denominator. So it becomes x to the negative 1. Okay. Now we can go ahead and find the derivative in terms of x, which is going to be 8x minus 4,000, x to the negative 2, and we are letting it equal 0. Okay. Now we can obviously bring that back down, so 4,000 over x squared, all right? And from there we're going to now obviously work with, simplify it. So like this, if that was over 1, we can find a lowest common denominator of x squared. That's going to give me x cubed minus 4,000. And we are going to simplify that. What does that come out to be? We're getting x cubed minus 500, which if we simplify, we're going to land up with x being equal to the cube root of 500 as your value for x, which is going to be the dimension of x for your cardboard box. to work out, which you can actually work out just as a decimal, okay, you can get that in terms of a decimal, and then so that would be your length and your breadth, and to work out the height, we would substitute your decimal value for x into there, and you would land up then working out the height of your cardboard box. That will minimize the amount of cardboard that you are using for your carton. Okay, so are you seeing a similar trend here? Okay, how are we working this out each time to maximize or minimize something? You have to start by establishing some kind of formula that represents the area, the length of a line, the volume of a box, whatever it is. And then once you've established that formula, letting its derivative equal 0 is what gets you to its maximum or its minimum. Okay, so keep at it. I hope this is making sense to you, and we'll keep doing examples. Okay, so see you next time.